Okay, so this is 7-2, solving exponential equations. And we'll look at some inequalities today also. Alright, so if you have a graphing calculator or Desmos, I don't care which one you have. Alright, we're going to put this equation in and see what it looks like, and then we're going to solve it algebraically also.
Do you have 2 Band-Aids? No.
I have some. You're now on the video for the rest of the classes to hear you asking for 2 Band-Aids.
Oh.
Thank you, Ivy.
Yes.
I'm just kidding. It's okay.
No,
Alright. So let's look at 2 to the x equals 8 to the third. Alright, so here's what I want you to do to graph this. So anytime you have an equation like this, you can set up each side so on Desmos as 2 separate functions and see where they meet, or you can set it up on your graphing calculator. Alright, so when they ask you a question like this as an equation, what they're asking for is what is x when these 2 y values are the same? So when this function's y value is equal to this function's y value, right? What are the x values? So if you're on a graphing calculator, in y1 you're going to put 2 to the x, and in y2 you're going to put 8 to the third. If you're on Desmos, then do f of x equals 2 to the x, and g of x equals 8 to the third. Alright, so I'll wait on you to do that. I'm going to do the same, hopefully. Maybe. Is Desmos opening for you guys?
Straight line.
You got it?
Actually, 8 is a straight line.
Yeah, 8 to the third is a straight line. Funny.
And it even graph it to the third. Do you hear me?
Do what?
I didn't even graph 8 to the third.
You may not be able to see it right. What is 8 to the third? How big is it?
It's a straight line of like 512.
Yeah. Alright, so while Google is trying to go to space and then come back, I'll sketch this. Alright, so we know y equals 2 to the x is an exponential function that looks like that. And 8 to the third is what? What kind of line? Straight one. Ha, funny. That was good. Horizontal. And where'd you say 512? Alright, so they meet at 9, 512. So you can find the intersection point on your calculator. You can find the intersection point on Desmos. So to do that on your calculator, you go to second, trace, which is calculate, and then intersection. It'll ask you to identify the 2 curves and then to guess the intersection point. 9, 512. Yep. So the x value is 9, y value is 512. So the solution to this equation is, what is x? What's the solution?
X would be 9, right?
Yep, x would be 9. So what this means when x is 9, so 2 to the 9th is the same thing as x to the third. So if I go on my calculator and I do 2 to the 9th, I go to my calculator and I do 8 to the third, I get 512. Is that true? Is 2 to the 9th 512? Does everybody know how to do that on their calculator? Okay. Yep. You got it. Okay, let's talk about how to solve this algebraically. Alright, so my bases need to be the same for me to be able to work out or solve the exponents. So I want my bases to be the same. This base is 2, this base is 8, not the same right now. but can you rewrite a base of 8 into a base of 2? 2 to the what would give me 8?
2 to the third.
Yep, 2 to the third. So I'm going to replace 8 here with 2 to the third. So 2 to the x equals 2 to the third, and then I still have that 3 on the outside also. All right, so what are your exponent rules? If I have something to the third and then to the third.
Did you add them?
Possibly. Possibly. No.
You multiply the inside first, and you multiply it by the cube on the outside.
Okay, you could do that. You could, but we want to keep the same base, right? So I'm trying to compare my bases, so I need this base to stay at 2. So I want to figure out those exponents.
Then you add those exponents together. Or multiply them together.
Yeah, I know. Which one is it?
Multiply.
You said both. All right. So this means this, right? So I add them if it's written like this. I multiply them if it's written like this. Do you see that I have 9 total 3's here? I have 3 and 3 and 3, so that makes 9. When I multiply these two together, I also get 9. I don't have to write it out this way, but I want you to see the difference between the two. This one I add my exponents. This one I multiply my exponents. I get the same answer. This is just a little less work, which is kind of nice. All right. Now that my bases are the same, I can set my exponents equal to each other, so x is 9. So your bases have to be the same. And then you can work with your exponents. Okay? Are we good on that? You guys want to try one? Of course you do.
These ones are next.
Yeah.
I'm not going to make it up because it'll be gross.
What did you say?
Me? No, I'm not. All right. So, for example, number 2, we want bases to be the same. So we have to say, what can I rewrite, or how can I rewrite 9 as a base of 3? So how did you rewrite 9?
We wrote it as 3 to the second.
So I have 3 to the second, and then that's to the 2x minus 1 equals 3 to the 6. So the goal is that you have the same bases, because once you do that, for these to be equal, your exponents have to be equal to each other. So now we talked about a power to a power. We're going to multiply those together. So I have 2 times 2x minus 1 equals 6x. Now it's solving an equation like you did in Algebra 1, right? So what's next? What's my next step to solve this?
Multiply it.
Yep. So would it have been okay to go ahead and multiply that up here and have 3 to the 4x minus 2 up here? Would that have been okay? Yeah. So if you did that, that's totally fine. All right, so multiplying the 2 through to everything, 2 times 2x is 4x, 2 times negative 1 is negative 2. And then we want all the x's on one side and numbers on the other. So now what's my next step?
Add the x's.
Okay, then?
Divide by 2.
Yep. All right, so now the question is, when I put in negative 1 here and here, do I get the same number?
No.
Answer over here. All right, so 9 equals, or sorry, 9 to the 2 times negative 1 minus 1 equals 3 to the 6 times negative 1. So 9 to the negative 3, right? 2 times negative 1 is negative 2, minus 1 is negative 3. Equals 3 to the negative 6. All right, so my bases aren't the same, so I really can't compare those, but you can put that on a calculator if you want to. So what is 9 to the negative 3? And what's 3 to the negative 6?
Same thing.
Okay. So that checks. So x equals negative 1 is the solution. All right, so what does that mean if I graph these two?
They're going to cross at 0.00. But that's from the same line, isn't it? They're going to cross there.
They're going to cross there. So the intersection point would be negative 1.00137, or 1 over 9 to the third, right? The negative makes this 9 go to the denominator. We talked about that with exponential functions. So this is actually 1/9 to the third. That's why this number is so small. So when you graph this, the intersection of these two, this is y1, this is y2, or this is f of x, this is g of x. The intersection point will be negative 1, 0.00137. Or negative 1. That's another way to write it. Okay? You want to try another one? Alright. You guys want to do it all by yourself? Sure. Challenging one?
Not too challenging.
Semi-challenging?
Like mid-core.
Like coach pitch. Alright. We'll do 2 more examples. So here's the first one.
You can't see it.
Oh. So 81 to the a plus 2 equals 3 to the 3a plus 1. Alright, I'm going to pause this so you guys can work. Alright, so we're going to change the base, right, to match. So we talked about 81 being 3 to the 4th. So I'm renaming 81 with the base of 3. And then this is still to the a plus 2 equals 3 to the 3a plus 1. Multiplying my exponents because I have a power to a power. So 4 times a plus 2 equals 3a plus 1. Everybody good with that? Distribute the 4 through. And then solve. Get all the a's on one side. And numbers together. So again, this is going to be a really small number because the negative exponent is going to shove the base to the bottom. So I have negative 81 to the negative 7 plus 2 is equal to 3 to the 3 times negative 7 plus 1. So 81 to the negative 5 should be equal to 3 to the negative 21 plus 1. 81 to the negative 5 is equal to 3 to the negative 20. That's the y value. So when you graph this and you go over to negative 7 on the x-axis or on the a-axis if you're on Desmos, this number is going to be really small, right? The negative pushes the 81 to the bottom. So here's the question. 1 over 81 to the 5th, is that equal to 1 over 3 to the 20th? Super small. Super small, right? So on your calculator, you should get really, really small numbers, and they should be exactly the same. This is all they ask you for. This is a check to make sure that it's right. See if the y values are also the same. You just throw it on your calculator. I mean, you don't have to write all this out. You don't have to write any of that out. You just have to put this in on your calculator and make sure. So put this and calculate the number, and put this and calculate the number, and make sure you get the same thing. I would do it just because it's a quick check to make sure you're right. Make sense? Okay. All right. Do you guys want to do one more before we go? Or you think you can remember? Let's do, we have 3 minutes. 3 minutes? Okay. I'll put one up and I'll put the answer to it, and you guys can just kind of see if you can get it right before you leave. We have about 3 minutes, so we're going to work on this some more tomorrow. So this is just foundational. Let's do. All right, so what's the target base between those two numbers? 3. Because you can change 9 to the base of 3, and you can change 27 to have a base of 3. It's supposed to be an A. Let's not use different letters today. That would be super challenging. All right, so try that. Yes, it does.
That's 27, right?
Yes. Hey, quit shuffling. You're supposed to be working. Stop shuffling. Ooh, it's a five.
So if we get a fraction, like, would you want us to turn it into decimal?
No, you can leave it. Did you guys get 5/3?
I got 1.
You did.
6a plus 2 equals 9a minus 1.
Minus 3.
Yeah. So this is negative 5. What's the answer?
5/3. All right, so we'll pick up there tomorrow.